Thanks. Hello, Banks.
Hey, hi. Can you hear me okay?
Yes, yes, I can hear you. And
Okay,
then,
you have a good background. Very good.
oh, it's actually the one sent by Timmy as a default one.
Okay, but I can't use the background
Oh, okay.
because I don't know. My computer doesn't support that background.
Oh, okay.
You had to
Okay.
have a green background, it seems, in order to use the background.
Oh, okay.
Something to, I don't know. It's only for Zoom. Otherwise, it works.
Oh,
Yeah,
okay.
and then anyhow, that's not an issue. Let me just turn on my video, make sure I look okay. See that background? You can see. Look
Yeah.
weird. Look weird.
Oh, that's very strange for you.
Yes. Let me take out. Okay. I think it's better without. Is that okay?
Yep.
Mhm. Yeah, should be okay. We start exactly 12, right?
Yes, I will start exactly at 12.
And then we have 45 minutes.
Yeah, including the Q&A.
Yep. I need to go fast.
Yeah,
Yep.
that's right.
It's fine. So how are the attendees like last?
Maybe I'll chat with you because I believe some of the customer will be able to listen to our conversation once they log in. Yeah.
Yep. Okay.
Mm.
Good.
Okay. Okay, Tini just confirmed that she can hear our voice.
Good.
As participant, great.
So I think in maybe 2-3 before 5 minutes, I'll share my presentation so that it's ready.
Okay.
Yep. Can you see my screen?
Yes, I can see your screen.
Great. Let me check. Yep.
Okay, I think we can start.
Yep.
Okay. Hello, everyone. Welcome to Agilent Technology Technical Webinar in Lab Indonesia. Today, we are going to talk about how Agilent solution is able to help you to help your food authenticity routine workflow. My name is Melda Tan, and I will be your moderator for today. Today, we are having the presentation from our speaker, Venkatesha, or you can call him Venks. He is our Agilent LCMS Business Manager. Following the presentation, we will be running a live Q&A session. Before we start the session, I would like to go through a few housekeeping. We'd love to hear from you during the presentation. If you have any questions that you would like to address, please send it through Q&A window, which is on the panel below your screen. When you're sending the question, please select all panelists in the drop-down menu and type in your questions in the text box provided. You can ask your question in English or Indonesian language, whichever more convenient for you. We will be addressing all the questions during our Q&A sessions. As time is limited today, if we did not get to your question during the session today, we will follow up with you afterwards. So without further ado, let's get things rolling. Thanks, please.
Okay, you can hear me, right?
Yeah.
Okay, great. Hello, everyone. Thank you for your time to attend today's webinar from Agilent. In this session, I'll be talking about the enhanced, or we can say a routine food profiling or authenticity testing using Agilent LC-Q-TOF. I mention again, it is a routine food authenticity testing, which is a very essential nowadays, as the false labeling or adulteration in food are a growing problem for food manufacturing. For example, if you take olive oil, right? So olive oil grade, a different grade, affects the labeling as well as the pricing. If you go to supermarket, you find a wide varieties of olive oils. It's not just varieties, all the price, if you look at it, it's a huge gap between the different varieties or a grade of olive oil. So usually this kind of a testing is done in sensory method, which is expensive, as well as it can be unreliable. So unbiased testing of olive oil to test the grade of extra virgin olive oil or the virgin olive oil is required for the quality purpose as well as labeling purpose. It's not only for olive oil, even manuka honey for that matter. If you look at the Australian authority number, whatever they give, the number of manuka honey exported from Australia and the available manuka honey in the market, if you see, there is a huge gap. Where is this extra manuka honey come from? So in order to test that, it's you need whether it is adulterated or the quality is there. Likewise, there is many applications are there which requires a routine classification. So today in this presentation, I'm going to go through the Q-TOF workflow using Agilent LC Q-TOF to do this routine food profiling or authenticity test, which includes LC-Q-TOF and some software tools like Mass Profiler Professional and Classifier Analysis Tool. Let's go and see how these analysis looks like. So first of all, what is profiling, right? So this is using a workflow where scientists trying to discover the differences in between two sets of data or two sets of sample or product, whatever you say. So in this approach, you acquire all the analysis in untargeted techniques. You try to extract all the peaks inside your maybe olive oil, different mango, honey, whatever does that matter, and then use the software tool to find out differentially how this, that these features are expressed, differentially expressed statistically. So using that, you build a model, something like that here, and which gives the red trace or the blue trace, and you use this model to predict whether your samples or unknown samples belongs to which group. That is the authenticity testing, whether it is adulterated or it is the pure. So we can use this to do a product quality test, something like manuka honey, is it from Australia, or saffron, is it authentic? And in terms of olive oil, is it really extra virgin? Whatever you are paying for the extra virgin, is it really true? So that is what we wanted to find out in an easy to use manner and a routine QA/QC lab. So what are all the challenges of doing this food authenticity testing? One is we may have to make sure that we meet all the regulatory requirements. And then you have to make sure that we have all the available authentic samples are there. I mean, the samples which you are building a model, good or bad, it has to be authentic. You have to make sure that this is original manuka honey. And the speed of analysis, we can't wait for 1-2 days or 1 week to get the analysis. It has to be faster, quick analysis. And then extensive method development. Sometimes it requires a lot of method development. People has to have a statistical idea how to get this model, everything. And validation also, in order to make sure that it really works, this model, whatever you created, good or bad, it really works. That is also very, very important. And these are all challenging, and in a real world it may not work. So in order to make sure it work, so the classification analysis is the simple and then the faster one, where It is a technique where you use unknown samples to predict a class based on the prediction model. You build a model, and then based on that, you predict whether the unknown sample belongs to one group, good or bad, something like that. Model build using a compound from known set of sample. As I said, you should have a known set of samples. You should have a Manuka honey from really coming from Australia, and then you take that and you build a model, good versus bad. Okay, that is very, very important. And then classification analysis has been, it's very useful for food authenticity or flavors or fragrance, or you can also see this is very useful in extractable or leachable testing as well, to make sure the product which is packed under certain package for a longer time, now extractable or leachables are come into the food which we are eating. Okay, in order to do that, we have to use a right tool. Okay, that is the simple and then very important factor. As long you use the right tool, you should be able to achieve. So what we have in Agilent in our company in LCMS system is we have LC-Q-TOF, series of LC-Q-TOF, not only the instrument as well as the different library and the schemometric analysis tool to do this analysis. Okay, let's go one by one. Why we need a Q-TOF, LC-Q-TOF, what it is going to do for. So in order to do any identification of a work, identification of a compound, you need higher degrees of confirmation. What you can get from QTOF is up to 4 degrees of confirmation. What are all those? First one is accurate mass, right? So you see here, you get a very accurate mass, in this case 404. And then you also see isotopic distribution. See, whenever you form a molecule which has a carbon, hydrogen, nitrogen, carbon has a high isotope. It's not just a C12, it is also has a C13. What is the effect of C13? You can see here, because of the C13, you get some additional mass here. Your QTOF should be able to measure that in your formula. That gives higher confidence. So that is isotopic distribution, or we call it as isotopic fidelity, right? At the same time, product ion, not just mass is enough, because there are millions of compounds in a chem spider or any uh, chemical database. When you search, you may not get a 100% hit. So you had to break this molecule, look for all the fragment masses associated with this compound. So MS or product ion spectrum is needed. And finally, you are running LC or a GC method, you need to have a retention time. So this will give you added advantage or additional confirmation of the compound. So LC-Q-TOF makes sense. So what is the difference between normal LCMS or a unit mass resolution LCMS and then QTOF MS, right? So you see here in a unit mass resolution like single quad, triple quad, you get a mass, but there is no further information. Even isotopic information is missing, or you don't have enough separation here or resolution here. But in a high resolution, you see a huge separation between your molecular mass as well as isotopic mass. Okay, that is the beauty of TOF, QTOF instrument or high resolution mass spec, which can be used for further development. Okay, let's go and look at food authenticity workflow. Okay, we got the QTOF ready, and let's see how the step-by-step analysis has to be done to make sure that we got the solution which we are looking for. So in order to do that, Agilent food workflow has a couple of steps. One is you have to prepare the sample preparation. So usually use a catcher's method to deal with this food matrix, and you use a cleanup, catches cleanup, or sometimes you use Agilent Captiva cleanup procedure, so that all these unwanted lipids and all removed, so that you have a good authentic or a good sample preparation done. And the later, the second part is separation and detection. Okay, it's all combined. Either you can use LC or GC to separate your compound using the chromatographic separation and detect using mass spectrometer. In this case, LC-Q-TOF or GC-MS Q-TOF. And finally, once you are done the analysis, next is extract all these ions, all these features, which is useful. And then once you have extracted, which is the extraction part is done using a feature finding. And final part is sample classification. How do you classify? One belongs to this group, another belongs to this. So let's go one by one. As I said, the first step is LC or a GC Q-TOF separation using LCMS or GCMS. And finally, find features in using a profinder, and the mass profiler professional will give you to build the model between good and bad. Sorry, between the good and bad. And then finally, you use a classifier tool, which is a QC kind of a workflow where people don't have to know all the steps, just inject the sample and get the answer. So this is the final automation step. You inject the sample here and compare with this model and you get your classification done. So this is completely automated. Inject sample and compare with this model. Only the two steps what QA QC people have to do in a routine application. That is the beauty of this whole workflow. Okay, so let's go one by one. The first of all, as I said, injecting this sample or getting the separation using chromatographic techniques, either LC-Q-TOF or GC-Q-TOF or other GCMSs. Then the first step is to have method development. Here you need some kind of expertise to understand step by step, where we have a profinder and then mass profiler professional statistic analysis tool. And the second step, you get the information from these. Okay, you get the profinder method, you get the model, only these two, and then the routine QC sample. They just collect, extract the sample, inject, and they'll get the report. Okay, as easy as automated. It as easy as like 3 steps. Like so, it's a complete workflow which automated sample classification. Okay, let's go one by one, how exactly it works. Let's say Profinder. What is this? When you inject multiple samples, right? So when you are checking the building this model, good versus bad, or control versus disease, whatever. So, or Manuka honey versus normal honey, right? You don't inject one sample, you inject a multiple samples in a replicates, and you have to extract those ions in a very faster manner. This Profinder software, MassHunter Profinder software, is designed to process a large number of samples quickly and incorporate innovative algorithms like the same as our MassHunter. The people using MassHunter, they know how to extract this. It will use the same method, and you should be able to do it faster manner. Okay, the fast compound finding and visualization and review and edit. You just make sure that different batches, it makes sure that all the peaks are there. If it is not there, it is only coming in one sample, no, it is a false positive, so that it will remove. That means minimize all the false positive, also negative. Very good data tool, and it works in an automated fashion. Once you have extracted, the next step is Mass Profiler Professional. Very important tool and the major tool in this process. What is this MPP? Okay, so or Mass Profiler Professional, right? Has a statistical analysis tool. You can perform many types of statistical analysis, ANOVA test, p-test, hierarchical clustering, whatever you know in the statistical, it can be done. And it can take the data from either LCMS, LCMS Q-TOF, or GCMS, GC Q-TOF, or ICP-MS, or other MS platforms. You can use that, convert, and then you can use it here. You can also do identification. Once your compounds are differentially expressed, for example, Manuka honey, you have certain masses very unique, what is that mass? You can also do some identification. Okay, these are all the very nice steps you can do. And people may worry, oh, how do I know which way to follow? Don't worry, we made this easy by making this method manager. Okay, the method manager means it works like HPLC method. For example, in a LC method, what is the flow, which column to use, what is the runtime, what is the retention time. Same way, you can design the experiment, select the experiment like a drag and drop task. You have a task and you can drag and drop and build your method. So something like this. So you have the MassHunter, Profinder archival, you have a create interpretation, filter by frequency, and a couple of additional steps. You can build this method and save the method. You don't have to worry about, maybe for some experts can build this method and then give it to anybody. Anybody can get the method and use it. However, if you are not familiar with these steps, there is a easy to use e-familiarization. It's a very good familiarization tool. It's available for new users with the software and the statistics. So any new user, if you want to learn this software, also know about the statistic technology, this ease familiarization is a very big tool. I'm not a statistician, but I should be able to do this analysis much more faster way. Okay, but anyhow, all this step is one time. Okay, routinely you don't do it. Okay, what you do is you acquire the sample using either LC or GC-Q-TOF, and you use only fewer step to get the report. Okay, only the second part. First part is usually done or validated by the experts or any method developer. But the routine classification, you don't have to do it. You just get the method from them. You acquire the sample, you use this one software called classifier, and then that's it. You get the result. So you have this sample table in this case, and also you have the result associated for different group of compounds. Okay. This MassHunter classifier is a very simple, uncluttered user interface for a routine analysis for the non experts or the people who don't have expertise. They can be used, this software can be used in a few mouse clicks. Okay, and get the results. You can run this for feature extraction, class prediction, and it can also do quickly process the samples to be classified, and it can using the PCA plot, and it can give you the result. So this is how the software looks like, MassHunter Classifier. So you have a couple of toolbar here to open the method, or I can say import the samples, and very visual toolbars. And then here is the sample table where you can see number of samples are there. And then this is the data visualization, how your sample fit in to this model. This model is coming from the method developer. And here is this one of the sample which represent this particular sample. And these are the some of the masses which is adding, which creates this tool. Okay, where this compound belongs to. Very simple to use, very easy to visualize also. And what we also have is this particular compound here, the black dot, is because of this sample, which is offload some mango sample. Okay, and easy report generation. You can generate a report and then you can copy this report. So it's very, very easy. And the reports, we nicely overview what you wanted to see as a classification analysis. Very beautiful. Okay, information on classified samples can be easily recorded and it can be reported. And you also have this PDF version. You can generate the PDF version of this file and then send it to your customer, whoever is looking. This particular workflow, machine learning workflow for classification, is not only for food analysis, even environmental samples to find out the source uh, apartments, so where the contamination is happening, or any routine monitoring. You wanted to monitor continuously the water quality. Life sciences uses a lot in a metabolomics workflow. Food analysis like food authenticity and a quality test, what I'm just checking, even in a biopharma to test off target effect. So for example, after a certain metabolism or drug altering metabolism, how the effect of your drug, and is there any issues associated with. So all this can be done using the same workflow. Let's look at one of the example, how exactly these different steps works. We have selected 3 different mangoes to prove this workflow, whether it works. And we collected, I think, 6 duplicates of these varieties, Tommy, Kate, and Atloff. And in total, we had some QCs also. We combined all adulterated samples. In total, there was 54 samples were extracted using a catcher's extraction. You can see a nice separation here between the sample and the extracted unwanted stuff. And then we collected that sample, injected into LC-Q-TOF, right? So after that, we used our software tool, whatever I mentioned just now, and the Profinder software and Mass Profiler professional software, and finally the classifier, 3 different software to develop as well as final tool for the classification. Okay, so this analysis was done using a LC-Q-TOF, Agilent, a new LC-Q-TOF called 6546, and we choose the mass 750 as the maximum mass. And we had a catches extraction. We have a simple liquid chromatography, reverse phase chromatography. We monitored from the 50 to 1000 mass range, and simple 10 to 12 data points across the peak, which is a regulatory requirement. You know, sometimes if you want to prove your peak as a proper peak, you need certain data points. So we make sure that we have enough data points across the chromatography. Simple analysis is done using Agilent new 6546 Q-TOF. Okay, what is this 6546 Q-TOF? Agilent just launched last year this new Q-TOF, which can give high resolution and extended dynamic range. It's very, very important. If people are using a Q-TOF, they realize either you can get high resolution or dynamic range. But in this new Q-TOF, you can do both together without any compromise. So high resolution means we have improved the resolution up to 60K for high masses, and we also have a low mass specification. For example, around 118, you can still get more than 30K resolution. In fact, in reality, you get up to 40,000 resolution very easily. There's new data independent acquisition modes also available. And in order to make sure that instrument is minimum downtime, we have a capillary gate wall so that you can clean the instrument without shutting the instrument. And then sensitivity will be same as our older instrument 6540, very rugged, robust instrument. So I was talking about the dynamic range, right? What happens when you inject your sample, there'll be a huge peak. And at the same time, there is a very small peak. Your instrument should be able to see both the peak. Here you see this particular compound, 10 to the power of 8, and this is 10 to the power of 4. The 4 times lower, but still we are able to identify that compound very easily. Right, so this is the 4 orders of magnitude or in spectra dynamic range, and the resolution of this instrument is fantastic. If you look at it, whether you run slowly at 1 hertz or 1 spectra per second or 50 spectra per second, your resolution always remains same, 42,000 42,000, around 42,000, all different specs. Even for the low mass, 117, you get a wonderful resolution up to 40,000. And not only just one peak or a molecular mass, you even for the isotopes, you have a better resolution and repeatability. You can look at the CV, very good CV for main compound as well as the isotopes are nicely detected with the repeatability. Okay, this is about the instrument. Let's go back to our analysis of mango. What I said, we took the 3 mango, Tommy, Keat, and then a float, and then we took it in a 6 replicates for each compound because we need more than replicates, more better the design is. And we also have a positive QC from each compound. We have one QC. Okay, that is to make sure that it is a positive QC. And also we wanted to have some adulterated samples, like means we mix these QC in a different ratio to make sure that this will become as a negative. So it is very important to design your experiment to do this analysis. One is number of duplicates, in this case 6 individual samples, positive QC to mimic pure samples, and also negative QC to mimic adulterated samples. And we also had different workflow randomized. We run first this compound, then QC, and then another compounds. We just run a randomized way to do the analysis. Look at the instrument performance. Wow. So after all these 54 injections, all these masses are very, very accurately measured from the theoretical to observed MASH, and then the error was less than 2 ppm. Very beautiful. And then the RSD, how number of injection, the RSD shows less than 6%. So it's a beautiful 5 days without delay, without calibration, without maintenance. We were able to achieve a wonderful result from using this instrument. Okay, so next is the batch extraction. You have collected the sample. Now I need to extract those, right? So for that, we use a Profinder. I was just told about. We import the sample file into Profinder. We select the batch and then build and save the method. And you can see this is the compound available in all the 3 varieties. And this is how you can align your compounds based on the different groups using Profinder method. In this case, there are more than 5,000 compounds found in these different varieties of mangoes puree. Okay, very, very wonderful experiment. Next step is a mass profiler professional or to do a statistical analysis. We imported this different features up to 4,000 or close to 5,000 features, and we did some statistical analysis, filtering by frequency, filter by annotations, and then some statistical analysis like ANOVA testing, and also p-value with 0.05. And finally, we ended up 1,500 entities from 5,000 to 5,500. And then finally, we applied the fold change up to 10 times. And then at the end, we have 480 or around 500 entities available after applying the fold change. Finally, we build the model using PLSDA, and this is how the model was look like. So each mango has a different variety as grouped together to get the model. This model is done. Now, for the routine QA QC analysis, do you have to go through this? No. What you have to take is you have to get that model like this, and you have to get that method. That's it. And you open the software. In the software, before opening, there is nothing inside. What you do is you select a Profinder method. You select a NPP model, which is already given or developed by someone, and then you put your sample information, load your sample, and then say submit. Okay. Once you did, you get this software which is filled up with all your samples, your model, 3-dimensional model as well as a 2-dimensional model, and then this is the compound table, which is which gives the model, right? Coming back to this three different samples which we did the analysis. So you remember with our 3 versions, we use a 6546 LC-Q-TOF to build this. We had a 6 biological replicates for this analysis. And we also had positive and then negative QC all from this compound. And if you look at this, this is the sample table. We have a couple of compounds, which is a pure compound, and some are mixture of 2 different varieties, 80-20 or 20-80, something like that. And if you look at it, those pure compounds have a very high confidence score, up to 0.9 or 90%. I can say 94, more than almost close to 90%. And those which is mixed, having less than like in this case 0.64 or 0.7, less than 0.7, I can say. So, and if you look at this particular dot, this is one of the negative QC. It is a mixture of 80% Keith and 20% Tommy, different varieties of the mango. These 2 mangoes, for example, Tommy and the Keith. And when you mix this together, that means it is adulterated, right? It will show out of this 3 group. Okay, it's not belongs to any of this group. So by this way, you should be able to tell whether this compound is adulterated or not. So QCs are very, very useful to make sure that your model, whatever the model you have built, is working. So based on that, we have created different varieties of confidence. And finally, if you see, if it is a pure compound, you should have a higher number of confidence, 0.8 to 0.9 something. And if it is adulterated, you have lesser confidence score. Okay, so those QC proved that anything less than 0.7 is not good. So, or less than 80%, it's not good. Okay, more than 80%, it's pure. Something like that you can consider. So very easy to use. So in terms and in summary, what I wanted to highlight, Agilent 6546 gives a very good resolution. You saw the resolution achieved up to 40,000 for the low mass, around 100, and then the good dynamic range, which is very, very important to make sure that you get the main peak as well as all those small impurities all or metabolites, right? Um, Mass Profiler Professional is a great statistical analysis tool, and the classifier software is good for routine classification analysis. Just remember this routine classification. You don't have to have extra knowledge. All QA QC labs should be able to do this. So Agilent can provide a one-stop solution for food authenticity with the brand new or a simplified application, I can say, which is the lower part is just inject sample and then get the result. Okay, with that, I'll end my presentation here. We have another 10 minutes to go through or see is there any questions available regarding this application. Because of the time, I have went a little bit faster, but if you want to know in detail how exactly this workflow works, please feel free to contact Agilent or our distributor Baka, so that we can reach out to you and go through with this in detail. With that, I'd like to thank you for your attention and see is there any questions available.
Okay, thank you, thanks for sharing the method. This is definitely helpful to ease our food authenticity routine.
Yep.
Now we have come to the Q&A session. To ask question, please select all panelists in the drop-down menu and type in your question in the text box on at the bottom. Feel free to use either Indonesian or English language, whichever ready. First one, how to determine the model construction to get reliable authentication? How big or diverse the model, and any guidance?
Okay, can you just repeat the question? Sorry.
Okay, how to determine the model construction to get a reliable authentication? How big and
Okay.
diverse the model is, and is there any guidance you can give?
Okay, that's a very good question. So, as I said, you had to run this with the different varieties, and especially you have to have a the one thing which I mentioned is a number of duplicates or replicates. The It is a very challenging application, but you can be made easy by the first step. You have to get authentic sample. Make sure that the sample you are testing is authentic one, and then you can build the model with the number of replicates, and the building of the method. You can either apply different varieties of model, PLSTA or other statistical tool to build the model. Once you build the model, you have to use this QC to test whether, for example, in our my experiment, I think if I go back, I saw some of them was 80-20 mixture. Yeah, in this case, we had a QC with the 80-20 mixture. So you had to find the different varieties of mixture to prove how your model is working. I mean, how much confidence level you should be able to achieve to make sure that this compound is pure or impure. So with that, we should be able to get the certain idea during the validation process.
Okay, thanks. The next question, can LCMS Q-TOF 6546 work for quantitative analysis?
Oh, very good. Give me 1 second. I'm trying to make this window bigger. Yeah, okay, sorry. Anyhow, yes, this is possible. The Q-TOF can be used for quantitative analysis. Actually, in fact, in my presentation, it was a combination of a quantitation as well as authenticity testing. But because of the time, I had to limit to the only authenticity testing. Yes, you are right. The Q-TOF can be used for quantitative analysis, and all ion MSMS mode is one of the best mode to use the quantitative analysis so that you can get a molecular ion information as well as product ion information. It's not because we can do it, it is the requirement from the regulatory. SANTE guidelines says you have to have a one precursor ion and one product ion with the better accuracy. So we were able to get less than 2 ppm as accuracy, and I think regulatory requirement is 5 ppm, less than 5 ppm, and we should be able to match without any compromise.
Okay,
Yeah.
all right. The next question, is there any consideration whether the extraction procedure affects the method development using the Profinder, MPP, and mass classifier?
Wow, very good. Of course, yes. Because that model, whatever you build, it has a certain, you have used a certain way of extraction. And if you varies that extraction, the model may not work. So the sample extraction, excuse me, is very, very important. And that's why sometimes what we do is we don't do very like SP cleanup and all, because we don't know what to target. That's why we do a simple extraction procedure, or maybe a catches extraction, so that you have a minimal sample cleanup and the rest will be taken care by the mass spec. But it has to be same, yes.
Okay. All right, next question. Have you performed analysis of unknown samples and projected into your existing model? Can you get confidence score?
Wow, yes, we have done this. I think when we created this mango experiment, I also have a couple of experiments from honey, actually. Actually, that samples were from Indonesia also. So we did this analysis for the honey testing and to make sure that unknown samples will fit into it. And for the current experiment, we did this on mango, and it worked very nice. I mean, as I said, we have this different QCs available with 20, 80, 90, 20, and with that we should be able to see where exactly it fits.
Okay.
Yep.
All right. So the next question is, can we apply same classification workflow using GCMS system?
Wow, yes. Yes, it's a very good question. If it is a LCMS single quad, it's not possible, but with GCMS single quad, you can still try. What I'm saying is the workflow, everything remains same. The classification workflow with MPP software
Mhm.
and classifier software is the same. But in a GCMS, what happens, whatever the spectra you're getting from GCMS is a fingerprint. So you can work with a NIST library and then you can identify. Since it is one of the plus point of a GCMS, you can still use a GCMS to build this model and or follow the same workflow. We recommend Q-TOF, of course, because you have a better mass accuracy, also better identification, but GCMS also works. But however, this is not true for LCMS because in LCMS, unit mass resolution, it is difficult to identify anything.
Okay.
Very,
So,
very good question, that one.
yeah. Right. Next question. Do we have to regularly tune the Q-TOF instrument compared to like a triple quad? If
Okay.
yes, how often?
Okay, it's not required. I mean, there are different tuning mechanism. In Agilent, we use a auto tune, and auto tune can tune the instrument, the complete instrument, the quadrupoles, collision cell, as well as the TOF tube, and it can perform like once in a month or sometimes 3 months once. Usually I don't do this, but there is something called calibration. Calibration means you don't have to build a calibration curve. Don't mistake me. There are two masses we always inject to make sure that all the ions are intact. Okay, that you may have to do once in a week. I mean, if you look at our the Mango analysis, we did this 1 week of analysis without any calibration. So that shows the results still looks better without any calibration, but we recommend do a calibration. It takes only 1 to 2 minutes only. And everything is automated. Just one click of button calibration. In two minutes, it will be done.
That sounds
Yeah.
easy.
Yeah.
Okay, let me see. Next question here. All right, the next question is, what is isotopic fidelity and how does isotopic fidelity help in the food testing workflows?
Okay, that is more for a food testing or the screening workflow. So what happens, as I think I mentioned in the, so this isotopic fidelity means when you have a compound which has elements like carbon, hydrogen, nitrogen, every element has its isotopes. For example, C12 has a, sorry, C carbon has a C12 as well as C13, and the ratio is vary. Okay, nitrogen has N14 and then 15, but if you look at some of the halogenated compound, chlorine has a 35, but it doesn't have 36. It has a 37. One isotope is missing there. So by putting all this together, when you have a final spectra, you should be able to see your molecular ion peak, and as well as you should be able to see your other additional peaks, additional isotopic peaks. This will give you, or it will enhance your confirmation like this compound or whatever the carbon, hydrogen, nitrogen is there, it is true representative. It's not just only one mass. The isotopic fidelity will help you to with the higher confidence to identify, also reduce the false positive.
I see. Okay, I guess we are near to the top of the 45 minutes, and as the time is limited today, if we did not get to your questions during today's webinar, we will follow up with you afterwards. And ladies and gentlemen, we have come to the end of our presentation. Hope the session has been useful for you, and we would like to say thank you again for attending. And just as a reminder, we will be having one more technical session tomorrow at the same timing. Do check it out. Thank you and have a good day ahead.
Hey, thank you all.